Okay, so we're into the second half of the Intermediate Maths Paper 2 from the summer of 2019. So we're into the C and B grade questions now. Question 9, write down the nth term of the following sequence. So the first thing to do, the trigger there is the nth term. So the learning that you need to remember then is you're looking at the gaps between the numbers. That is giving you what the n rule is. It's going up in threes, so it's a 3n rule, and then which basically means it's a shifted version of the 3 times table, but the first number is in 3, so it's not going 3, 6, 9. You've actually got to move it 5 places to go from 3 to 8, so it's a 3n plus 5 rule. If you haven't revised nth term rules, it's well worth doing. They're really easy, quite easy marks. Make t the subject of the formula. This is often something that we don't spend much time on in the intermediate tier, but if you're good at dealing with equations, it's the same rules you use here to solve equations. What they're saying is at the moment this is r equals, you want to get the t on its own to get t equals. So the first thing we have to do here, if I rewrite it, is get rid of the take 8, which we have to do by adding 8. If I add 8 to this side, I have to add it to this side as well. So this side now becomes r plus 8, not 8r, but r plus 8. And this side just becomes 3t, because the plus 8 and the minus 8 have gone. To get the t on its own, I have to get rid of the 3. The 3 is joined to the t by a times, so I have to divide by 3. If I divide that by 3, I have to divide this side by 3 as well. 3t divided by 3 is just 1t, and this side then becomes r plus 8 all divided by 3. So your final answer is t is r plus 8 divided by 3. If you're confident with solving equations, that's an easy extra couple of marks. Part C. A rectangle has a length of x plus 5 and a width of 2x minus 3. Its perimeter is 46. Okay, so this is a geometric context for solving equations. Sometimes they can be angle properties, sometimes to do with perimeter or area. It's well worth practicing the different types. So let's just kick ourselves off with a diagram. So the length is x plus 5, the width is 2x minus 3, and the perimeter, the distance all the way around the outside, is 46. So I know that if I add these together, they're going to come to 46. So if I form an equation, start again, I got 2x minus 3 there, plus an x plus 5, plus another 2x minus 3, plus an x plus 5, that comes to 46. That's into the marks now. We've formed our equation. Let's simplify it. Gather up the x's. 2x plus 1x is 3x, 5x, 6x. Take away 3 plus 5 is 2. Take away 3 minus 1 plus 5 is 4. You could have done that from here. You could have just worked it out. 2x, 3x, 4x, 6x, 5, 10, take away 6 is 4. The key thing is you get down to that line. If you can solve equations, you're laughing. I want to get the x on its own. First of all, I deal with the plus 4 by getting rid of it, by taking 4. If I do that, I have to do the same to the other side too. On this side now, I'm left with 6x, because the plus 4 take 4 have gone. And on this side, 46 take away 4 is 42. The 6 and the x are joined by a times, so I have to divide by 6. If I do that to the left hand side, I've also got to do it to the right hand side. 6 divided by 6 leaves me 1x, or x. 42 divided by 6 is 7. So if you can solve equations, you can get 4 marks there, 2 marks there, plus the equation earlier on. You can pick up a lot of marks. Okay, so marks for that question. 1 mark for 3n, 1 mark for plus 5. For part B, 1 mark if you get it down to r plus 8 equals 3t, so your first step for isolating t, and 1 mark for your finished answer. And for part C, then there's 1 mark for your string of algebra into an equation, 1 mark for getting it down to 6x plus 4 equals 46, or 2 if you just write that down straight away. Then the next mark is for getting it down to 6x equals 42, and the final mark is for getting x equals 7. Question 10. So this was the first question on the paper when I was flicking through, and I thought, oh no, that's cruel. Is it possible to draw a right angle triangle with the measurements shown below? You must use calculations, not a scale drawing, to support your answer. You must show all your workings. So we've given a triangle and we're given the 3 sides on it. And students that haven't read the question just automatically think that this is a trig question to find an angle. It's not a trig question, it's actually a Pythag question. So if we go back to our sheet at the start, then our sheet at the start is a squared equals b squared plus c squared, where a is the hypotenuse. So that would be a, that would be b, and that would be c. Now Pythagoras only works in a right angle triangle. So if it's a right angle triangle, what will happen is your a squared, 25.6 squared, will be equal to what we get if we do 12.8 squared plus 22.7 squared. So if that adds up to that, it's a right angle. If they don't add up, it's not a right angle. So let's figure out 25.6 squared is 655.36. 12.8 squared is 163.84, and 22.7 squared is 515.29. Okay, let's add those up. And we get 679.13. So if it was a right angle triangle, they would be the same. They're not equal, so it's not a right angle triangle. Pythag doesn't work, so triangle isn't right angled. And the reason I groaned with that was because usually when we introduce Pythagoras in year 8 or year 9, you will get questions which ask you, is this triangle right angled. But then as we do lots and lots of past paper questions in year 10 and year 11, usually you're using Pythag and they're telling you it's right angled. That's the first time in a long time I've seen one where that comes up. So that was a bit cruel, but perfectly entitled to ask that question. So how was it marked? Well, the strategy mark was for recognizing you wanted to use Pythag to test it. Then the method mark was for actually putting in your values and showing that when you're comparing them, you don't end up with the same thing. And then your final conclusion that it's not right angled. So, bit of a nasty one there. And this is the second nasty one on the paper really, because it's to do with Venn diagrams. But for the first time, they've actually asked for some set notation. And I'm not going to go through this with you in this particular question, because you either know it or you don't. Where you have an overlap like that, that's called the intersection, and inside there would be numbers that are in set A and set B. The intersection, the algebra for that is that one. And then for part B, the shaded bit here is saying any values that aren't included in set B. So basically anything that's not in set B, and the not B is this one. So again, bit like the Pythag question, when you were introduced to Venn diagrams in year 9 or year 8, you may have covered that, but in every other past paper question, they've been working with putting data into the Venn diagram rather than the proper notation behind it. Question 12. Look at the following set of 4 numbers. 5, 8, 10, 13. Find another set of 4 numbers so that the range has increased by 2, the mean remains the same, and the median has decreased by 1. You may use some of the numbers from the original set, but not exactly the same 4 numbers. Okay, so for the original set, the range, biggest takeaway, smallest. So original range, or given range, would be 13 take away 5 is 8. So the new range needs to be 2 bigger. So I'm looking for a list of numbers where the gap between the biggest and the smallest is 10. The mean remains the same. So we add them up and we get 10, 18, 23, 36 divided by 1, 2, 3, 4. 36 divided by 4 is 9. The new mean remains the same. So that basically means my 4 numbers have to add up to 36. So total must be 36. So I'm looking for the numbers, biggest takeaway, smallest is 10. They've got to add up to 36. And the median, so the median in this case is going to be halfway between the middle pair, which is going to be 9. The median has decreased by 1, so the new median, remember the median is the middle. If it's an even set of numbers, there is no middle, so it's halfway between your middle pair. Decreased by 1, 9 take away 1 is 8. So, biggest take away, smallest is 10. So if I was to start with 5, that would be 15. That would mean so far I've got 20 and I want to add up to 36, so I need those two to add up to 16. So if they were both 8, that would add up to 16, and the median would be 8 as well, as would the mode, but we don't need to worry about the mode in this particular question. So there's a mark because the range is 10, so I get 1 mark for the range 10. I get 1 mark because the mean is the same, they add up to 36, and I get 1 mark because the median is 8. They aren't the only ones. You could have had 5, 5, 11, 15. You could have had 5, 6, 10, 15. You could have had 5, 7, 9, 15. Any of those groups would have got you the full marks. Question 13. A company has 3 sites based in Wales. One is Carno, one is in Holyhead, and one is in Porth. The pie chart below show the distribution of its 128 female staff and 72 male staff. So this represents the female, this represents the male. A person is chosen at random from the company's 200 staff members. What is the probability that this person works at the Porth site? So we need to get that information from our pie chart. Now we can see straight away that Porth in this pie chart is a quarter of the pie. But just so that we stick with one method for finding information off the pie chart, to turn an angle into a quantity, you write down what fraction of the pie we're talking about. So for female workers in Porth, that will be 90 degrees out of your full pie, 360, times 128, because that's what the full pie represents. 90 out of 360 is the same as a quarter. Fraction 90 out of 360 times 128, so there's 32 females, and then from this graph, sorry, this pie chart, we need to work out the males. So the angle for this one is 120. Often they won't tell you that and they expect you to measure it, but in this particular question they've given it to you. So 120 degrees out of the 360 represent the male staff working in Porth. The whole pie represents 72 of them. So same again, 120, 360, 72. So people working in Porth, there are 32 female, 24 male. A person is chosen at random from the company's 200 staff members. What's the probability that this person works at Porth? So probability works at Porth would be how many of them work at Porth? 56 out of how many workers altogether? 200. Check it's not asking you to simplify it. It's not, so just leave it as it is. If you wanted to write that down as 28 out of 100 or 28%, that would be fine, but it's not asking you to, so leave it as it is. Okay, marks for that. There's 1 mark for working out the correct fraction. So So either writing down a quarter or 90 over 360, and 1 mark for the site of 32. Then there's the third mark is for the 24, and the final mark is for adding those up and putting them out of 200. Question 14. Right, we're on a maths paper and we're on the calculator allowed, so we're expecting trig and Pythag. Pythag usually crops up first, and it did, and we've dealt with that. So I'm expecting this to be a trig question. This time it's telling me that I've got a right angle triangle. It's telling me that the side PR is 16.7 and QR is 9.6. Calculate the size of, and that little hat there is telling me it's an angle, and it's the angle that takes us from Q to P to R. QPR is this angle here. So if I call that X, that's what I'm trying to find. Right, so I got my little notes that I wrote down at the start of the exam. So I know I've got the SOHCAHTOA. I've got to label my sides. So the opposite is the one that's opposite the angle we're trying to find. So that's my op. The hypotenuse is pointed at by the right angle, and what's left is the adjacent. Now, because I'm trying to find an angle, I need to know two sides. So I have to use opposite and hypotenuse. So the one that links opposite and hypotenuse is the sine triangle. So let's bring that on to my work. When you're trying to find an angle, you cover up the S or the C or the H. So sine of the angle is O over H. So sine X is op over hyp. Sine X equals, so let's substitute in, opposite is 9.6, hypotenuse is 16.7. So when you practice in trigonometry, you need to remember that if you're trying to find an angle, you've got to get the X on its own, which means you have to do the opposite, the inverse of sining. And if you look on your calculator, you'll see that above the sine button, you've got the inverse of it, which is sine minus 1. So we write sine minus 1, 9.6, 16.7. So to do that in your calculator, shift and sine, fraction button, 9.6 on top, 16.7 underneath, close the bracket. So I've typed it onto the calculator identically to the way that I've written it. Gives me that answer. It doesn't ask for a rounding, but they're using 1 decimal place, so we'll use 1 decimal place. And to 1 decimal place, it's not a 0 because the next one is close, 8 or bigger, 5 or bigger, so it rounds to 1 degree, 0.1, 35.1 degrees. So that's a really straightforward trig question. If you've been practicing trig, that should be just the most straightforward thing. So you've got a method mark for writing sine of whatever you've called the angle is 9.6 over 16.7. Then you've got another method mark for writing it as an inverse sine, and an answer mark for 35.1 degrees. Question 15. So this is a simultaneous equation question, buried in context. Sometimes they'll just give you a straightforward one in algebra, other times it's in context, so it's the luck of the draw. The Morgan family and the Smith family are on holiday in Aberystwyth. There are 7 adults and 2 children in the Morgan family. There are 4 adults and 3 children in the Smith family. Both families visit a craft centre. The entry price for the craft centre is X pounds for adults and Y pounds for children. The total cost for the Morgan family is £41.50, and the total cost for the Smith family is £29.75. Form two equations in terms of X and Y. Solve your equations using an algebraic method, so you can't use trial and improvement, to find the entry price for adults and the entry price for children. So let's go back. So here are the two lines which are going to form our equations. 7 adults, so one adult is going to cost X, 2 adults 2X, 7 adults 7X, and 2 children, Y 2Y. That's going to come in total for the Morgan family to £41.50. Then for the Smiths, 4 adults, 3 children, £29.75. So those are the equations that we're going to solve. Now there are lots of different ways of being taught how to deal with simultaneous equations, but usually on the intermediate tier we just fix on one so you don't get confused by choice. First thing we always do is to number our equations so we know what we're working with. Then we want to get the X terms to be the same. So to get them the same, we multiply the first equation by the number in front of X in the second. So we do equation 1 times 4. We multiply all of that equation by 4. So we get 4 times 7 is 28x. 4 times 2 is 8y. And £41.50 times 4 is 166. Call that equation 3. Then we take the second equation and multiply it by the number in front of the x on the first equation. And do that for the whole of the second equation. So I'm going to do 2975 times 7 equals £208.25. So the point of doing that was to make these the same. Now the reason we want to make those the same is so that when we take those two equations away from each other, we get rid of that x term. Again, you may have been taught this differently, but often it's just the same method so you don't get confused. So now we're going to take equation 4 from equation 3. So just like a subtraction, 28 take away 28 is 0, so the x's have gone. 8 take away 21 is negative 13. 166 take away £208.25 is negative £42.25. Now it's important that you do that correctly, because sometimes these are pluses and minuses. So 8 take away 21 is negative 13, 166 take away that is that. To get the y on its own, I have to get rid of the times negative 13, and I do that by dividing by negative 13. If I divide that by negative 13, I have to do the same with that. That leaves me 1y on that side, and on this side £42.25 divided by negative 13, £3.25. So y is £3.25. Then to work out what x is, I replace the y in the first equation. So I say substitute y in number 1. So it becomes 7x plus 2, but now I know that y is £3.25 So I can evaluate that. 2 lots of £3.25 is £6.50. I want to get the x on its own, so I have to do the opposite of adding £6.50, which is subtracting it. If I do it to one side, I have to do it to the other. So this is just now the straightforward equations we were solving earlier. £41.50 take away £6.50 is 35. Divide by 7, divide by 7, I get 1x is 5. 35 divided by 7 is 5. So x is £5, y is £3.25. Simultaneous equations are another area of intermediate tier maths which looks really complicated, but is a fairly repetitive process to learn. It's something that you can easily revise and practice in an hour and be able to solve any of them, so long as your basic laws of equations are strong. So it should be, if you decide to master it, easy marks. Okay, marks for that. So there's 1 mark for forming the equations. There's a method mark for getting it down to a point where you've got rid of the x's. So getting it down to that line earns you a mark, and working out the value of y gets you that mark. Then the next method mark is for substituting that value in, so you get another equation now but only with x in. And then the final mark is for your second value, so for the x value. It's really worth practicing that. Question 16. A solution of the equation 2x cubed plus x minus 10 equals 0 lies between 1 and 2. Use the method of trial and improvements, there's your trigger, to find this correct to 1 decimal place. Okay, so it's going to lie between 1 and 2. And we're going to be counting up in 1 decimal places. So your answer is either going to be 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 or 2. One of those is going to be our answer. We've got to decide which one. We want to eliminate as many as we can as quickly as we can. So the best place to start is 1.5. So we try x equals 1.5. Inside our formula, that means that instead of writing x, I'm going to write 1.5, and it's worth putting those in brackets. So if you imagine the x is a pair of brackets the wrong way around, and when we want to put a number in there, we smash it open and they fall the other way. So they go from there to make something that we can put a number in. So 2 bracket 1.5 plus bracket 1.5 minus 10. Type it onto the calculator exactly as we've written it. 2 bracket 1.5. We've got a cube button. Okay, that comes to minus 1.75. I'm looking for 0, so that value gives me an answer which is too small, and it's important that you write that in. So if that's too small, then there's no point me trying any of those numbers, because they're going to be too small as well. So my answer is somewhere between 1.5 and 2. So I'll try 1.7 next. Could try 1.8, doesn't matter. 2 bracket 1.7 cubed plus minus 10. So that's positive. So that's too big. So if that's too big, there's no point me trying anything bigger than that. So my answer lies between 1.5 and 1.6. So I want to get it to decide now whether it's between 1.5 and 1.6 or 1.6 and 1.7. So now I try 1.6. So 2 bracket 1.6 cubed plus bracket 1.6 minus 10 negative. Excuse me. So that's too small. So if that's too small, I can disregard that bit as well. So my answer lies between 1.6 and 1.7. So one of those is going to be my answer. The next bit is really important. So far we've earned 2 out of the 4 marks because we've chased it down to a choice of those. So now to test, I need to go halfway again. So if we redraw what we've got here now, 1.6 is there, 1.7 is there. Halfway between 1.6 and 1.7. If you're not sure, think about that as £1.60 and £1.70. £1.65 would be halfway. So we go to 1.65. And figure out what that is. See if that's too big or too small. Too big. Now if that's too big, that means those are all too big, and our answer is between 1.6 and 1.65. Any number between 1.6 and 1.65 to 1 decimal place rounds to that. So we can say, so x equals 1.6 to 1 dp. If that had worked out to be too small, so if that had been negative, then those would have all been too small. Our answer is in that region, and anything there rounds up to 1.7. So we get 2 marks for getting it to consecutive between 1.6 and 1.7. Then there's a method mark for going halfway between, and an answer mark for then showing which is your final answer. Question 17. So we're on the last but one question on the paper, so it's grade B work. When a number is reduced by 15%, the answer is 6,154. What is the original number? So when we teach reverse percentages, we bang on all the time that if you come across a question in the second half of the paper that seems too easy, it probably is, think again. This is just one of those. So because it's been reduced by 15%, the multiplier will be 100% less 15%, which is 85%. So whatever the original is, we multiply it by 85%. Okay, so what is the original? We multiply that by 85%, and that gives us the output, the reduced value. So I want to find out what the original is. So I have to go backwards through my number machine. So when you go backwards through a number machine, you do the opposite. So the opposite of timesing by 85% is dividing by 85%. So on my calculator, what I'm going to do is 6154 divided by 85%. So 7,240. So when you reduce 7,240 by 15%, you get 6,154. So what we are getting here is 1 mark for recognizing that that is 85% of the original, a method mark for dividing by the 85%, and an answer mark for 7240. Reverse percentages is a pretty easy thing to practice, so it's well worth doing. It's just a question of you spotting that if you get a percentage question so far into the paper, then that's what you need to do. And then the final question is on circle theorems, or angle properties within a circle. And these are things you either know or you don't, so I'll just go quickly through this one. ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral in a circle with a center O. So a cyclic quadrilateral is if you have a four-sided shape inside a circle where each vertex, each corner of the four-sided shape touches the circumference of the circle. If that's the case, then there's an angle property which tells you that the opposite angles in a cyclic quadrilateral add up to 180. So x is going to be 180 less 126, which is 54 degrees. And the reason opposite angles in a cyclic add to 180 degrees. So if you've practiced circle theorems, that won't be a problem to you. If you haven't, that will mean nothing. And then the second one, I now know that this is 54, and we've got this arrow-shaped relationship where that angle and that angle, the inside one is twice the outside one. So if that's 54, y is 108, and the reason angle at center is twice the angle on the circumference. And again, if you've practiced circle theorems, that will be fine. If you haven't, it'll mean nothing to you. So, mark scheme, there's a mark if you've just got 54, and there's an exclamation mark if you've managed to word that in one shape or form. And similarly, there's 1 mark for the 108, and an exclamation mark if you've explained why it is 108. So that's the end of the paper. For me, that was a really fair paper. There's only a couple of traps in it. The Venn diagram question wasn't very nice, and the Pythag question was disguised. But apart from that, there were some really nice questions there.